So today we're going to be talking about the slack loop. Now, what is the slack loop? It is the area between the feed and the straightener, and the loop is induced through going down deep into a pit, and what that does is that gives you amount of material to match the pace between the straightener and the feed. Now, why would we need to do this? We need to do this because your straightener cannot accelerate as fast as your feed can. So we start to have to go into this scenario of anticipating that feed's movement by paying off the straightener in a consistent fashion, and for the feed to be able to have enough loop to consume and to not overcome that straightener. We liken that to a bucket of water. Now, if you look at this bucket of water, if we had 10 gallons per minute going into this bucket and 10 gallons per minute coming out, that is matching the pace of the two faucets. What can happen is that this faucet can't open and close as quickly as this one. If this one is opening and closing and the overall is 20 gallons per minute, but this is only letting in 10, we have a problem. And that slack loop allows us to get into that rhythm, because at the beginning of a startup of a press, you cannot have your straightener accelerate as quickly. So that's what overcomes it. No matter what you do, no matter how much horsepower or torque you have on your motor and your straightener, the amount of force required to accelerate that as quickly as your feed would exceed the gear's ability to distribute the force, would exceed the amount of grip required to go through, because you have to back bend your material. Another thing that we have to concern ourselves with concerning the slack loop is something you can induce after your straightener. You can induce what's called up curl or down curl. That's induced by exceeding your minimum bend radius. Your minimum bend radius is a term for the amount of curvature that you put into your material before it starts to reshape. So if we're flat and say we have a quarter inch piece of aluminum and I bend that aluminum, if I were to take my hands off and it's supported in midair and it has a new shape to it, I've exceeded its minimum bend radius. We can do that unknowingly by having a catenary section that is too abrupt, so it has too much of a curvature to it for your material. And also, if you have a catenary section and you've set your loop too shallow, you can have it hit just one of your rollers on your catenary section, and that can also induce up curl or down curl. It can exceed your minimum bend radius. So these are the things that we have to be concerned with on the slack loop. We have to set the depth at the correct height. We have to make sure that we have the correct catenary sections. We have to make sure that our straightener feet per minute overall are the same as the feed feet per minute overall, or if you're in Europe, we use meters per minute, or they can use, there are different ways of using it, but it's all in the metric system. So that is essentially what we're concerned with, is being able to keep a consistent supply of material to your feed and your press to make your part and make sure that your material remains flat.